In this video, I'm going to show you how to create your own scale drawing of the Earth's interior using this image. Notice that on the left, it says to scale. That small image of the Earth's interior is to scale, but it's way too small to be useful. On the right, we can see all the layers and thicknesses, but it is not to scale. So your job will be to make one that is to scale. Your final product will look something like this. You can see that the scale is 1 centimeter on paper is 300 kilometers. And I'm going to walk you through how I got that and how I drew it so that it looks to scale. The first step in doing a scale drawing is to determine how much space you have to work with on the paper. I'm using a piece of computer printer paper, which is a little bit less than 28 centimeters long. I need to fit the entire thickness of the Earth on that piece of paper. The Earth has a radius of 6,400 kilometers from the crust to the very center. I'm going to do some calculations in my notebook. First step always is to put a title in my notebook: Earth Structure Scale Drawing, Scale Calculations. Now I need to determine the scale. In this case, I want to fit 6,400 kilometers in real life into less than 28 centimeters on paper. I wonder what the longest scale is that I could fit on my paper if I filled the entire paper. So I'll choose 27 centimeters as the length of the paper. I'll divide 6,400, which is the number of kilometers in real life, by 27, and let's see what I end up with. That would give me a scale of 237 kilometers per centimeter on the page. The problem with using that scale is that it would fill the entire paper. It would leave me no extra space on the paper. So I think I'll try something a little bit smaller. I'm going to try a larger number of kilometers, and that will shrink my scale. It'll fit into smaller space. Let's try 300 kilometers in real life per 1 centimeter on paper. Let's see how long the Earth scale drawing would be in that case. I'm going to take my total, 6,400 kilometers, divided by that scale, which is 300, and that gives me about 21.3 centimeters. Well, that works out really well because if I put that on my paper, it gives me a few centimeters on either end to play with for title and things like that. I think I'll use that scale of 300 kilometers in real life is 1 centimeter on paper. To make the scale drawing, I need to figure out for each layer what the thickness is when I scale it down to the paper. So I'm going to make a new entry in my notebook, and on that page, I'm going to make a table with 3 columns. The first column I'm going to label layer, second column thickness in real life, and the third column thickness on paper. Don't forget to put the scale so that we have that as a reference on the top of the page. And then I'm going to go through each layer and figure out what the thickness is on paper. We will refer to the thickness data from this image for each layer. I like to start from the bottom. So we'll start with the inner core. And the inner core has a thickness of, well, it goes from 6,400 kilometers up to 5,100 kilometers. You subtract that, the thickness would be 1,300 kilometers. Then we get the outer core, which has a thickness of, well, it's 5,100 kilometers up to 2,900. So that's a thickness of 2,200 kilometers. I will keep doing that for all of the other layers. Now I need to determine how thick each layer is, and I do that by dividing the thickness by the scale, which is 300 kilometers. So the first layer will be 4.3 centimeters thick on paper. The second layer will be 2,200 divided by 300 is 7.3 centimeters thick. The third layer is the same, and I do the math for all of the other layers. So now I am ready to draw my scale drawing. I have all the data set up. I know that the total thickness of the Earth from the crust to the center is going to be 21.3 centimeters. So I'm going to make a series of lines that all converge at a point, and this will give me my sort of wedge shape that I'm looking for. And each of these lines will be 21.3 centimeters long. You may notice that I actually made a small mistake, which will come back later, but it's easy to correct your mistakes if you're measuring carefully and double checking. So I'm going to make a series of about 4 lines that will allow me to make a nice curve shape later and also to double check my measurements. So starting with the first layer, the inner core, I will start at the center, and I know that that first layer is going to be 4.3 centimeters. So I will make a mark at 4.3 centimeters along each of the 4 lines. And then when I'm done, I will just freehand an arc across the 4 lines to show the curve. You'll notice, oops, it looks like I made a mistake on that third line. So it's easy to tell. I clearly was off by a couple of millimeters. I can make that correction easily and then make a nice smooth arc. Then we will move, and I will label that as the inner core. And then we'll move on to the outer core. We know that the outer core had a thickness of 7.3 centimeters. So I'll do the same thing. I will go up from the outer core 7.3 more centimeters. I will do that at each of the 4 lines, and then again draw an arc across those 4 lines. And that will be the outer core. Then I will do the same thing for the lower mantle, which again is another 7.3 centimeters from the outer core. It was at this point that I realized my mistake. That right hand line was about a centimeter too short. I could tell because it was clearly shorter than the other 3 lines. I just remeasured it, added a centimeter. And it's for that reason that it's really nice to use a pencil when you're doing this. So then I just continue the process for the middle mantle, which is known as the asthenosphere, the upper mantle, and the crest. Finally, there's some labeling to do. We want to label whether the layers are solid or liquid or plastic, which is kind of a solid that can flow like the asthenosphere is. We also want to label the temperature of each of these layers. So when you're all done, your scale drawing of the Earth structure will look something like this. As we go from the center outward, we can see that the temperature is 5,000 degrees Celsius at the temperature. It cools off as you get closer to the center. We can see that it sort of has this alternating solid, liquid, or plastic layer. Um, and of course, at the top, we have the scale labeled and we have a nice title.